So what I mean by that is, if there's anything about the sample you picked, if you picked it in the wrong way, if you picked it without letting randomness happen, we'll talk about that in a minute. If I pick just you guys, you're all here at this time, you're all in math class with me. So what have I not allowed for if I pick you as my sample of Grossmont students? You're supposed to be representative of Grossmont students. Why are you guys then really a bad sample? Why are all these things going to skew my data results? What have I not accounted for? So for example, like you said, we're here right now. So what's wrong with that? Yeah?
Well, like, people have kids, maybe like they take later classes, like at night.
All right, good. So that would obviously, now we're kind of making the connection. Something like that might happen enough to totally skew our results, and our results would not represent all of Grossmont College. You with me? So to be truly random then, everybody, oh, this is big. Anytime I slow down when I'm talking, it's big. To be a random sample, each element, oh, that's math speak. Everybody cool with the word element? Each member of the population must have an equal chance to get into the sample. So believe it or not, there have been major studies done where the flaw was actually in how they chose their sample. So they report all, holy crap, we found a correlation between eating a lot of butter and living to be over 100. Oh my God. And they picked their sample only came from people who live in a certain part of the world, where they do other things that might make them live longer. It's not the butter. It probably is not the butter. Don't go home and eat tons of butter. Stats teacher said to do it. So what's one way I could then make it a better, what would we have to do? I can't just pick you guys. You guys would actually be what's called a convenience sample. It's very convenient for me because you're here. Right? If I ask you to do a survey, you probably will. Right? In fact, before I forget, there is a survey I want you to do later.
Yeah, because it's new.
I know. I just put it up there. Don't worry. This morning. What would we actually have to do then? If we want to do this study, want to see what's the percentage of Grossmont students who have kids? How can we make a sample that's better than just picking you guys? What's one approach we could take? What's one problem that we identified? We're all here at this time. And as you said, some people might come take later classes because of, it might be because of kids. You never know. So what's one thing we can do to make it better?
Walk around the campus asking random people.
Related to the time issue.
Some different days and times.
Beautiful. So both of those things, you're right. So I could walk around the campus. I might want to make sure they're actually a Grossmont student because you've got people wandering who aren't. Who just, I'm in college. Walk around, go to different classrooms, right? At different times, different days. And that would actually get it closer to being truly random. You with me? Okay. To make it really, really random, you might just want to get like a printout of all the students at Grossmont College and just start throwing darts at it or something. Or pick random numbers and assign it to the students, you know, and then pick random numbers and pick those students. You guys kind of with me? That would take away all the variables, because even if you walk around, there might be some people you don't feel comfortable talking to for some reason. They're muttering to themselves and their hair is all sticking up. I don't think so. And that's not really random then. You've then excluded them from having a chance. That's not random. I can't trust your results. Sorry. Cool? All right, so now we're getting this idea, and it's going to become very important, obviously, later, about how the sample is picked. If it's not picked correctly, I can't trust any of the data. Now, even if I pick a perfect random sample, I do that. I get the computer printout, I get the computer giving me some random numbers, and some of you guys might realize this, that random numbers generated by computers are not necessarily truly random. Well, let's not get into that. Let's say I have a perfect computer that does that. And I do everything. I could possibly, it's not impossible for me to end up with you as my sample. Is it likely if I do all that? If I print out all 20,000 student names and I roll a giant die 20,000 signs? And I pick all these students randomly. It's not impossible that it would be just you guys. You understand? Is it likely that it would be you guys? No, hell no. That's very unlikely. That would be incredibly, like, holy shit. Right? So we want to identify in statistics. I know very often I don't use, correct terminology. There are those moments where it's not holy shit, and there's those moments that it is holy shit. We have to, at some point, there's got to be a defining line between those. Right? So if I flipped a coin 1,000 times, and I got 999 heads, is that a holy shit moment?
Yeah.
Hell yeah. If I got 900 heads, that's still a holy shit moment, really. But the 999 is like, what the hell? Actually, I'm thinking about that one time it didn't. Of course, I'm also worried about my life. I'm flipping a freaking coin 1,000. All right, where do we leave off here? So, I mean, a lot of these things you guys have heard of. Some of you guys had the idea of this. Right? We're going to kind of define this a little bit better as we go throughout the semester. One way to define this better is to talk about all the different types of samples that aren't this. All the different mistakes that can be made. But I really want to stress, I could do exactly like I said and get nothing but women in my sample. And that's a truly random sample. Is that a good sample? No. So that's what I was saying earlier. If you want to be really careful and have representations from all these subgroups, then you pick randomly from each subgroup. So I can have a list of men, a list of women, and pick randomly from both. That way I'm assured that I have some of each. Or at a high school, I could pick some freshmen, some sophomores, some juniors, some seniors, right? So that I have an equal representation across all the different classes. Okay. Keep myself on track. Let me talk about this here real quick. The number that we get from this. So let's say we do this study, we get the sample data, and we do the analysis. We look at the percentage you have kids. Let's say I have, we see 32 people with kids out of, let's say, 78 people that we talked to. All right, somebody help me out. What percentage would that be? Quick little, can you do a percentage quiz?
Well, it's under 50%.
Exactly. So 32 is less than half of 78, so it's definitely going to be under 50%.
41.
Yeah, so it's going to be a little bit higher. 40% of 80 would be exactly 32, so that makes sense. So 41% of our sample have kids. You with me? I'm going to say that's a yes. That is what's called a statistic. Right? That is a statistic. Believe it or not, there's a word in statistics that is statistic. So, a statistic, here's the really cool thing. A statistic describes a sample. Statistic, sample. You with me? So that is a statistic if it comes from a sample. The thing we're trying to say something about is the percentage of people at Grossmont who have kids. Can I just say 41%? Hell no, because that's true about my sample. But I can say my best guess for this. Oh God, Jim, that's really awesome. My best guess for this is 41%. And in chapter 7, and you've all seen this before, especially with elections, Proposition 30 and whatever, and you see 44% will vote. And what do you always see at the bottom?
Plus or minus.
So 44% say yes, 43% look to say no, and at the bottom it says give or take like 4%. That's just, of course, they put that down to cover their ass. Not really sure. But we're actually going to see the math that gives us that number in chapter 7. So this I might want to report this as plus or minus 3% or whatever. And that's not just something we can. I'm really not sure. Let's say plus or minus 6. No, that actually comes from a formula. It's kind of cool. So we'll see that formula in chapter 7. This would be a parameter. And again, look, parameter describes a population. It does not happen often enough in mathematics, but it just did, right? Parameter goes to population, statistic goes to sample. All right. Very exciting. Let me see what else I want to do today. Oh, I do want to say something real quick about something the book makes a big deal about, and this is actually huge for later. So for something to be statistically significant, so there's a problem that's going to come up later in the book, and it says there's a new diet out to help people lose some weight, and it's been shown that it does cause people to lose weight. On average, they lose a pound and a couple ounces. But it's statistically significant. Now, what the hell does that mean? That means that actually that number, they had a large enough sample to say, yes, it appears that the diet does actually make people lose weight. So it has statistical significance. And another way to look at it, you guys kind of with me, right, so far? So there's a new diet. We're studying to see its effectiveness. We do a study. Let's say we do look at 3,000 people, and we all put them on this diet, right? And overall, they lose on average 1 pound and a couple ounces. Statistically, it'll come out and say the probability of them doing that, just randomly us picking 3,000 people who were going to lose that weight already, is so low that it must have been the diet that made that happen. Let me say that again. So we got 3,000 people we pick. We put them on this diet. They lose weight, on average a pound or whatever. And the statistics will say the probability that that would have happened just by itself, randomly, is so low that what's more likely is your diet caused it to happen. How you guys doing? Because there's always a chance that we just happen to pick 3,000 people who are going to freaking lose a pound anyway. Right? You with me? I could just do that. But what's the chances of that? It's so low that what's more likely is it was your diet that caused that to happen. So that's what statistical significance means. Yes?
Wouldn't that also include something like the placebo effect of being on that diet?
Yeah. I mean, we're not...
Okay.
Yeah, don't worry. We're not going to get into the whole psychology of it yet.
Okay.
For right now, I don't want to get too deep. I just want to describe the term.
Okay.
So the term means what it does, independent of placebo effect and all this other stuff. So you got to worry about that. You're right. Yeah.
When you say diet, do you mean the product that they were selling?
Yeah, it could be a pill, or it could be a different way to eat. Only eat foods that start with the letter B. I don't know. Right? I'm sure that exists out there. Every day you eat a different letter. Whatever. Yeah. All right. Where did they go? Now, is it practically significant? How much weight do people normally want to lose? They go, I really need to lose a pound. Well, this does that for me. We normally want to lose 10, 15, 20. So is that practically significant? No. Statistically, it says the diet did have an effect. But such a small effect that it's not practically significant. Another example I like to give is, if it was discovered that if you slept 16 hours a day, some of us have probably already done that, but if you slept 16 hours a day, you'll live another couple months. And it's statistically significant. It's been shown. Statistics says, yes, the probabilities look like it's more likely it's because of them sleeping than just because you randomly looked at these kind of people. So statistically significant. Is it practically significant? Do I want to give that much more time away from my day? Are my dreams really that great? I don't know, maybe they are. That I want to sleep my life away like that just to tack on more life? Is it practically significant? No. So practically significant means, does it make me want to change my life somehow, or does it mean something about changing my ways? No. Statistically significant is just the numbers, just the math. Yes, it is a difference. It is shown statistically that it does something. Practically, it's not good enough. Right? Okay, so that's going to become important in this section, actually, section 1, 2. They make a big deal out of the difference between those two. Where else do I want to go here? All right, we'll do a little bit more, and then we'll head out a little tiny bit early. Don't get used to it. We're going to get more specific now on the types of data that we can talk about. So there's two main categories, and then we're going to subdivide into some further categories. And I got to get used to the book now uses different terminology than we used to. There's quantitative, and there's what I still am going to call qualitative, what the book calls categorical. Of course, that loses some of the nice alliteration, some of the nice QQ. I mean, come on, we want to go away from that, but I won't. So, what's your gut feeling about data that would be quantitative?
Numbers.
And when you say numbers, you have to be a little more specific, believe it or not. Numbers that actually measure something.
It's like when your example is dealing with numbers and percentage, and then when it's categorical, it's like dealing with gender and race.
Yeah, exactly. So categorical, that name actually makes it a little easier to identify what the hell it is. But this would be stuff like hair color, gender, type of car you're driving.
Yeah.
Right? These are more names, and these are more true numbers. Numbers that you can actually subtract and do stuff with. You with me? So like jersey numbers, I'm number 72. Do I subtract that from the guy next to me and that means something? No. That's my name. That would be more qualitative. So this is, I always think of this as measurements, possibly, or other numbers that, other true numbers. If I just say that, is that cool?
Mm-hmm.
When I say true number, I mean a number that I can subtract and it means something, divide and it means something, maybe. Okay. Qualitative is more just names, hair color, stuff like that. Categories. That's what I call a category. Okay. That's pretty straightforward, I would hope. So where would Social Security number go? Yeah, qualitative, because you can subtract Social Security numbers all you want. Does it mean anything? No. All right, so there's some subcategories. There's 4 subcategories. And 2 of them kind of fall into this one, and 2 of them kind of fall into this one, but it's not such a hard line, but don't freak out. It's not going to really mess us up. What's going to mess us up is how to tell where things fall. So let me try to explain what these things are. The first 2, there's one called nominal, and there's one called ordinal. They kind of go together. They're more qualitative types. They're more purely names. In fact, nominal, does anybody know what that root piece, that nom, refers to? Name, because like plume de nom. For example, Stephen King, when he first started writing books, he was actually under the name Richard Bachman. That was his plume de nom, his pen name. So nom means name. Nominal then would just be purely names or categories. No order. So what do I mean by inherent order? Because that's what this is. I mean, that's pretty obvious. That root word, or just ordinal. The ordinal numbers are the numbers that come in order. Ordinal requires some kind of inherent order. So if I say names of cars, you're not going to say it's ordinal because you can put them in alphabetical order. That's an order that we impose. So if I had a list of cars and I said Hyundai, BMW, Mazda, blah, blah, blah. Is anybody going to yell at me? Maybe my really, really, really OCD people, but is anybody going to go, wait, dude, wait, the hell? It's not in order. What's wrong with you, Jeff? No, you're not going to do that. If I put that at the bottom and I made these bars, a lot more people have Hyundais than anything else or whatever. You're not going to go, no, Jeff, what the hell, man? Put the BMW first, is B. No, you're not going to do that. It doesn't have to be in alphabetical order. But if you're at a restaurant and they say, rate our service, and they put down there, good, fair, excellent, poor, and you're what? Right? Then you're going to go, what's wrong with you guys? Right. Is there a way to rate this itself? You must rate your rating card, you know? Yeah.
Oh, sorry.
That's all right.
Just stretching.
Oh, okay, that's all right. But you guys get the difference between what inherent order is. It means if I write it out of what it wants to be and it looks weird. It's not acceptable. So ordinal has to have an order it must be in inherently by itself. Nominal is just names. I could put in an alphabetical order or something else, but that's something I would impose. They don't have to be in that order. You guys with me? Now everything that's here is also this. These are still names. So it kind of builds on each other. So when I ask you what level of data is this, you always give me the highest level. This is the lowest level because I can do the least with it. This is the next highest level because now there's an order to it, right? And then the next two higher levels are then quantitative. Now we're talking about these are the things I can subtract and divide and all this kind of stuff with. I can do a lot more with it. Okay, sort of decent so far. Okay. So the next two levels, and I think we'll head out after this, are interval and ratio. So these two are the ones that are, this is not a hard line, but these are normally qualitative, and you can see why. And these two are normally quantitative. And you'll see why in a minute. Which one of these, let me see if anyone gets, which one of these sounds like it should involve division? Yeah, because a ratio is defined to be that division bar in the middle, right? So interval is anything that, any data that I can actually subtract and the answer means something. Because I could subtract jersey numbers. Now I'm 72, I'm sitting right next to 12, minus 72 minus 12 is 60, we need number 60. No, it doesn't mean a damn thing, right? You can subtract them, but does it mean something? Hell no. So interval would mean where the subtraction makes sense. So a good example of that would be year of birth. Right, you with me? Year of birth. So like dates or years. Year of something. So if I was born in 1972, and who's looking at me? Nobody's looking at me. They're all averting their eyes. You were born in
91.
91. What happens when I subtract those? I don't know, Jeff. It's been too long. So you got 19. What's that 19 mean?
The difference between your two ages.
Yeah, I'm 19 years older than you are, right? So that has physical meaning. That 19 has physical meaning. It means something. If I divided those 2 years, would I get a number? The correct answer is yes.
Yes.
Would that number mean something? No, not a damn thing. Yes, ma'am.
For interval, is it only subtraction? Like, we're only like subtraction makes sense, or it could be like addition or...
Trying to think of a good example. Well, I mean, you know, in a situation, in this situation you and add is normally subtraction. I'm sure I could come up with a place where addition would make sense, arbitrarily. But normally the subtraction would represent distance between two things.
Okay.
Addition might not, in this case you can see it would, adding those two dates wouldn't really do anything for us. Now ratio is where, that's why year of birth or something like that does not belong in ratio, because ratio requires division to make sense. And actually there's two things that this one requires. So division must make sense. I swear to you this is English. Division must make sense. And here's the neat word with another one with an inherent. There must be an inherent 0. So for example, the year 0, does that mean nothing has happened yet? This is the beginning of time.
No.
Of course not, right? I like the way you... No, it's not. Of course. 0 degrees. How many guys know 3 temperature scales real quick? Anybody know 3 temperature scales? There's Fahrenheit, Celsius.
Kelvin.
Good. Kelvin is the one where 0 means we're all dead.
0.
0 means no energy. All the energy's gone. But so forget Kelvin. You with me? We're not in chemistry class. Forget Kelvin. When I say temperature, I mean our everyday temperature. The 0 degrees Fahrenheit mean the absence of energy. Can it not get colder than that? You can get colder than that, can't you? Ask the people who live in Minnesota, for example. So there is not an inherent 0 in temperature. So where would temperature belong? What level would temperature be at? Yeah, because I could still subtract. Take yesterday's minus today's, and we'll see how much colder it is today, right? It is a little colder today. So ratio would be something like age. If I'm 40 and you're 20, I'm twice as old as you. The division, 40 divided by 20 is 2. The number I come up with makes physical sense. Not just can you divide them and get a number. Does a number mean something? That's what makes it ratio. Plus, if I'm 0 years old, I've not been born yet. Right? Age kind of tracks the amount of time we've been on this earth, actually out, air hitting us in the earth. Right? It doesn't count our womb time. Right? I wasn't doing that poor woman. But it's time that we've been out here. So if at 0, or if I go fishing and I say, how many I caught a fish with 0 inches long, it means I didn't catch any damn fish. Right? It's the absence of fish. So 0 must mean what it's supposed to mean, the absence of. Cool. What about profit? This is the last example. I want to let you guys. What about profit? Where would profit fall?
It depends.
Because could you have 0 profit? Could you have less than 0 profit? Yes. But think about it. Is 0 in this right place on the scale? Does 0 mean the absence of what you're measuring? Yes. If I had $4,000 profit last year, and then an $8,000 profit this year, 8,000 divided by 4,000 is 2. And that 2 makes sense. I'm making twice as much. You kind of with me? So don't just think that because there's something below 0 that it's automatic. It's just a question of is 0 in the right place? On the Fahrenheit Celsius scale, 0 is not the right place. It's an arbitrary placement. You can get colder. Doesn't mean the absence of energy. But 0 profit means the absence of making money. Right? Negative means it's flowing the wrong direction. Okay. All right. So again, this is a very quick introduction. You desperately have to go and read that chapter 1. Start trying to do the homework in chapter 1. We're going to finish it real quick next time. So if you haven't looked at chapter 1 yet, look at it. Come ready with questions. Oh, last thing. Thank you. Something that everybody must do. A lot of you guys have gone here already. As somebody pointed out to me, there's something brand new here. These 2. You must fill these 2 out by next Monday. They're pretty quick. I'll show you what they look like. Bang. Blah, blah, blah. And real quick, so there's a few questions. One of them's anonymous. I ask you kind of like what's your political leaning and all that kind of crap. I don't want to know that specifically about you. I just want to know for percentage problems later. So it's anonymous. What does this mean here? Yeah, 8 plus 1, and you put 9 there. I had people like zooming in on that, saying, what does that mean, Jim? That's just so that it's not a robot filling out surveys, you know? So they always say, sometimes they'll have those, please write the word, and you're like, I can't see that word, give me another one. This is just a little math problem. So don't freak out when you see that. So fill out those 2 surveys by next Monday. And on Wednesday, I'll let you know how many people still need to do it. All right. So see you Wednesday.
How do you know about the Boston
You need to add to it, come up and see me.
Some people don't know about the Boston.
Oh, I love Stephen King.
I think there was someone whose entire
Oh, really?
biography, or not his biography, his entire memory.
Yes, I did. What's your name? Here you go. Unfortunately, they gave me... Oh, good. It is. You all need to add to it? Or? Okay. Okay, cool. There were a couple crashers. Okay. Sure.
Can you send out those emails, like all those stuff in emails today? But I never opened the box.
Gotcha. Double check your email address and web advice.
I normally do get them, but
And when did you enroll? Was it a while back?
Well, I was first on the wait list, and then I got like added, like I got an email saying I got added in the class.
And that was how recent? Because I
A
did send an email out
couple
to,
weeks ago.
oh, really?
Yeah.
So you probably should have gotten an email from me. I
Yeah.
did get a couple bounce backs. So you did get an email from me?
Yeah.
You did? Okay, cool.
Well, a while ago, just kind of like,
Last week, right?
it was like,
All right, so double check and make sure, I called your name on there for
Yeah.
being enrolled, right? Okay. So just check your email and web advisor. If it looks right there, send me an email so I can double check and see what I have on my end. But that's where I get my emails from. It just downloads from the web.
right.
For those of us,
It's like, I get
For those
emails
of us
from my professors, so like I always have to check that and then just move it into your inbox.
Do I just find it on the website?
Oh, no, I'm
Thank
sorry.
you.
You don't have to do
Wait,
anything.
oh, okay.
Yeah, go ahead. You can do it. Don't worry about the ad.
Fill in our name.
And then also paying,
Yep.
can I pay on Friday and still pay, or do I have to pay right away? I know it says.
I'm pretty sure it has to be paid right away. Because they, like on the 18th, they dropped anybody who hadn't paid yet.
Yeah, I know that.
So I think when you register, it might come with a little word saying you must pay.
Yeah, it does.
honestly
I
don't
was curious, but okay.
Okay. I got that riveted.